Okay, everyone, we're going to take a look at using trigonometry when we have non-right triangles. So law of sines and law of cosines we always use specifically for non-right triangles, while we use our standard trig ratios when we have right triangles. Okay. The key thing about law of sines, it can be used to find either a missing side or a missing angle. You just kind of have to make sure that you're able to fill in all these individual variables, okay? And the real big thing that you need to make sure you know is that your little lowercase a is a side across from angle A, okay? And then B and C are your other two sides. All right, so when you go to use law of cosines, you need to, let's say if you're wanting to find a missing angle, you need to know all three sides so that you can fill in that expression and solve for capital A. Or if you're looking for one of the sides, that means you either are looking for the side across from the angle and you have B and C, so you have the other two sides, okay? Or you have a side and the angle across from it as well as one of the other sides, okay? Law of cosines is the one that I think has a bit more fluidity to it. You can use it for a couple of different things, while law of sines, I think, to my opinion, is a bit more strict in that you always have to have a side and the angle across from it. Okay, so let's say we would never use in law of sines all three of these expressions at the exact same time. This is just showing that you can use any angle and its opposite side to make this whole expression work. But we would really only ever use two of them at a time, depending on what side and what angle you have. But the key thing between law of cosines, law of sines is a bit more restrictive because you have to always have a side and angle across, while in law of cosines you don't, depending on what you're looking for. However, law of sines is probably a little bit quicker to use because you're using less variables at once, versus law of cosines, you're frequently using several different things in the triangle. So they kind of have a give and a take to them. It's not uncommon that you have to start with one and maybe finish with the other, if you're wanting to go in kind of for speed, which I'll show you on the next problem. When it comes to law of cosines, I know you might see we have two different equations here. They're really not different equations. They are the same. They're just reworked for different things. The top one is worked so that you're solving for a side, while the bottom one is worked that you're solving probably for the angle here, okay? They're the same formula. You could start with one and solve it yourself by hand to get the angle, but you're given both of these in your formula packet. So if you know you're looking for that angle A, you can go ahead and use the bottom formula rather than the top one. That way it's already worked out for you and you have less work to do on your end. Okay. If you're ready, I'm going to go ahead and move on and go through an example problem on the next page that uses both law of cosines and law of sines. Feel free otherwise to pause if you need some more time to write or need to go back and kind of re-listen to something. Okay, so in this problem, they've asked us to find all missing sides and angles of this triangle, and we do not know that this is a right triangle, so we have to use law of sines and law of cosines to do this, okay? And I'll take a note of what I have in this picture. So if I've got two sides and an angle here, I notice I do not have the side across from angle C. Okay, so this would be little c. I don't have that side, which means I do not have a side and angle pair in order to use law of sines right now. So I'm automatically restricted to law of cosines. I'm going to have to use law of cosines to make this question work. Okay, in this case, what I can do, I know in law of cosines, my original was this. Okay. Now those letters don't exactly match up to the ones that I have in my picture because really I'm supposed to have A and the angle across from it, but I don't in this case. That's okay. I can readjust these letters to more match the picture that I have. I know that I have C and the angle across from it. So that would mean C squared equals a bunch of stuff cosine of capital C. Okay. These other variables in here are really just the other two sides. In this case, that's side A and side B. So I'm going to go A squared plus B squared minus 2AB. Okay. So you can readjust those letters if you ever need, or if you don't even have letters A and B, you can just adjust them yourself to be like PQR or something like that. Okay. So I'm going to go ahead and erase the one that I have up top, because now I've got my new law of cosines here for me. And if I want to find C, I'm going to go ahead and plug everything in. So C squared equals A squared. Well, that's the side across from angle A, so that would be 10 in this case, so 10 squared. Plus B squared. Well, that's the side across from angle B, in this case 16 squared. Minus 2, again times 10 and times 16. Cosine, I have my angle is 55. Okay, if I want to solve for C, I'm going to then square root both sides. So rewrite 10 squared plus 16 squared minus 2 times 10 times 16 cosine of 55. And if I type that into my calculator, I will get 13.13223 ... And for now, I can round that to 13.1, okay? I just need to make sure that when I go to find my angles, if I use that 13.1, I use the unrounded version of it. Now, though, that I have a side and the angle across from it, now I'm no longer restricted. I can go ahead and move on to law of sines to find everything else. So over here, this was law of cosines. Now I'm going to use law of sines. I could use law of cosines again to find these missing angles now that I know all three sides. It's just a bit tedious. There's a lot more involved in that formula than with law of sines. But since law of sines is now useful, it'll be a little bit quicker. Okay. So that's going to be sine of whichever variable I want to use, in this case sine of angle C over little c, equals, let's say I want to find angle A first, so I'm going to go sine of angle A over little a. Okay. So I'm going to go sine of 55 over, remember I need to make sure I use my unrounded version of this number, 13.13223 ... equals sine of A, I don't know the angle, over little a is 10. I'm going to solve, so that's going to give me 10 sine of 55 over 13.13223 ... equals sine of capital A. And I need to use my inverse trig in order to get angle A. So I'm going to go inverse sine on both sides. So that's going to give me, I'm going to move kind of this direction. So I'm going to drop a little line here. Inverse sine of 10 sine of 55 over 13.13223 ... close parentheses, that equals my angle A. And if I simplify using my calculator, I get if I round to 3 significant figures, 6 degrees, okay? I could do law of sines again to find angle B, but if I'm fairly confident that I just got angle A properly, 38.6 degrees, again, using the unrounded version, I can just subtract from 180 all the angles that I know. So 180 minus 55, that would give me 125 degrees. Then subtract off the 38.6 that I just found for angle A, and I would get 86.4 degrees for angle B. Okay, and I could do law of sines to verify that, just to make sure I did everything right, but there would be all the missing angles and all the missing sides of that triangle using law of cosines and law of sines. Again, if you have any questions, I would encourage you to ask in class. We're going to do some practice, that sort of thing. But thank you all for watching.